I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss stationary points. We'll begin with answering the question, what are stationary points? And then see, how do you classify them? We'll also take up 4 different examples to understand the complete concept. Let me thank all my viewers and subscribers for sharing brilliant questions. This question has come from one of our subscribers who wants to understand how do you find the stationary points and how do you classify them. So, we'll discuss how do you find and classify stationary points with the help of these 4 examples. Now let's begin by understanding what really stationary points are. Now stationary points are the points where they're also called critical points. Let me write the other word, critical points. So stationary points or the critical points are the points where the first derivative is equal to 0. First derivative equals to 0 means that it is neither increasing nor decreasing. So that gives us 3 different conditions. So at stationary points, we could have something like a maximum where the derivative is 0 means horizontal line will be tangent, or it could be a minimum where a horizontal line could be a tangent. So we have identified 2 different situations where this critical number called stationary point is either a local maximum or a local minimum. However, there is another condition also. So it is not necessary that it could be a maximum and a minimum all the time, right? The third condition is, let me sketch a graph to explain. If I have this function like a cubic function, as you see, the derivative is also 0 somewhere here, right? Because this is a horizontal tangent. Now this point is neither a local maximum nor a local minimum. What is this point? Well, this point here is point of inflection. So we have the third condition also, which is we could have point of inflection. Is that clear to you? Now we are talking about stationary points in smooth curves. As shown here. So I hope this part is absolutely clear that if you have a smooth function, then the critical points or the stationary points are the ones where the derivative is 0. Now at this point, you could have a local maximum or a local minimum or a point of inflection. Now how do you classify them as maximum minimum? What is that characteristic which helps you to find whether it is a local maximum or minimum? So to do that, what we do is that we analyze first derivative. So if first derivative changes from positive to negative, so if it changes from positive to negative, of course this is 0, then what we get is a local maximum. However, if it changes from negative to positive, what we get is a local minimum. Is that clear to you? But what happens if it does not change? if it does not change the sign, like here, you see it is positive, right? So here we have a positive, right? Here also it is positive. So before and after the 0, it is not changing the sign. In that case, what you really have is a point of inflection. Is that clear to you? So very clearly, we have figured out that a critical point is a point, or a stationary point is a point where the first derivative is 0. But if it changes, then we have a local maximum or a local minimum, and if it doesn't change near that point, means the change of sign we're talking about. In that case, it is a point of inflection. Correct. Now let's take up these examples to understand in details. So we are given a function f of x, which is x squared minus 2. Let's find the derivative of this function. Derivative will be 2x. To find the critical number, equate it to 0, right? So we'll equate this to 0. That means 2x is 0, right? That means x equals to 0. So at 0, we are going to analyze the derivative about 0, right? Near x equals to 0. So for that, what we are going to do is we are going to take a test point. So here we have x equals 0. We know derivative is 0. We'll take a test point before and after. So let it be x equals to minus 1 and plus 1 before and after. And let's analyze the derivative, which for us is equal to 2x. Now, if I substitute this value of minus 1, then what do I get? Well, I get a negative value, and if I substitute plus 1, I get a positive value. It means that the derivative is negative, means the function is decreasing, and here the function is increasing, right? And that means we have a local minimum. So we have local minimum at x equals to 0. So to find the point, we have to find what this point is, right? So let's find the value at 0. So we have 0 squared minus 2. So we know f of 0 is equal to minus 2. And therefore, we can now write down that the stationary point let's call it point P, which is 0 minus 2, is classified as a local minimum. So I hope that is absolutely clear, right? So these are the steps to be followed, correct? Let's take up the next example, which is f of x equals to x cubed minus 3x plus 2. So the procedure to be followed is find the derivative, correct? Which in this case is 3x squared minus 3. Now, find critical number. Means it will equate the derivative to 0. Means 3x squared minus 3 equals to 0. Right? You can take 3 common. You get x squared minus 1 equals to 0. So we get a value which is x equals to plus or minus 1, which can satisfy this equation. So we have got 2 points, right? One at plus 1, the other one at minus 1. We can also directly find the value first, right? F of 1 will be 1 cube minus 3 times 1, right? Plus 2. And that gives you a value which is 1 minus 3 plus 2, or is equal to 0. So we have this point at 1, we have 0, correct? Similarly, let's find the value at minus 1. So we have minus 1 cube minus 3 times minus 1 plus 2, right? Which is minus 1 plus 3 plus 2. 5 minus 1 is 4. So we have a point at minus 1 which is 1, 4, correct? It's a cubic function. We got these 2 points. And now we will analyze the first derivative. So to analyze the first derivative, we know that we have an interval defined by two critical numbers which are at plus and minus 1. So let's take the value of x equals to minus 1 and x equals to plus 1 and check some test points near them. So minus 1 will be minus 2 on the left, 0 in between, and 2 on the right side. The derivative is 3 times x squared minus 1. And if we check whether it is positive or negative, if I substitute minus 2, we get a positive value. Substituting 0 will give us a negative value. And then with 2, we have a positive value. That means the function is basically increasing, right? In the interval before x equals to minus 1, decreasing in between minus 1 and minus 2, and then again increasing. Now, when the function is increasing and then decreasing, it gives us a local maximum at minus 1, and then decreasing to increasing gives us local minimum at plus 1. So we can say that the stationary points, we can classify these points, correct? So we have two of them. One is 1 and 0. And at 1 and 0, we have a local minimum, right? And then we have at minus 1 and 4, which is local maximum. Is that clear to you? So that is how we need to work with these polynomials. Perfect. So there are two more questions to go. So here is the third one, and then we have here the fourth one, correct? So I'll leave one of them for you. So we got x to the power 4 minus 2x squared. I'll leave that for you as a practice question. Now let's take the last one here, which is 4x minus x cubed. Steps involved are, first find the derivative, right? Which is 4 minus 3x squared, and that gives you a 0. So critical number equated to 0 means 4 minus 3x squared equals to 4. So you can now solve 3x squared equals to 4, or x is equal to plus or minus square root of 4 over 3, which gives you two values, plus or minus square root of 4 is 2. So we can write this as 2 over square root 3. Makes sense, right? So we got this value. Now we need to analyze these points, right? So to analyze, we have two zeros. One at x equals to minus 2 over square root 3. The other one at x equals to plus 2 over square root 3. Let's take a test point in between these intervals. In between them, we could take 0, and this is 2 over square root 3, right? So 2 over square root 3, we can take a point here, let's say minus 4 on the left side, and plus 4 on the right hand side. And let's analyze the derivative, which is 4 minus 3x squared. If I substitute minus 4 for x, I really get very high value of negative, right? So 4, so this will be negative. Substituting 0 will give me positive 4, and that will be negative. So we see that the function will be decreasing in the interval before minus 2 by 3, and then increasing and then decreasing. So clearly in this case we have a local minimum and then we have a local maximum, correct? So local minimum is at x equals to minus 2 over square root 3, and local maximum is at x equals to 2 over square root 3. Makes sense, correct? So, we again have these two stationary points, one of them being local minimum, which is at x equals to minus 2 over square root 3, and the local maximum as 2 over square root 3. So I hope you have understood how do we find, in this case, I'm not calculating the y value. You can always check the value for minus 2 over square root 3, and so that you get both the quadrants, right? Plus 2 over square root 3, correct? And then write down your answer. So I hope that helps. So with that, we have taken up these three examples. The fourth one is your test question. It's a polynomial in degree 4. Now, work on these things and figure out how to find out the stationary points, how do we classify them, whether they are local maximum, local minimum, and remember, they can be point of inflection also. Perfect. I hope it makes sense. Feel free to write your comments, share your views. If you like and subscribe to our videos, it'd be great. Thanks for your time and all the best.